In this question, we've been asked to work out the integral of a natural log of x over x squared, and we can work this out using the integration by parts. We need to move this denominator to our numerator. So we'll have the integral of the natural log of x multiplied by x to the negative 2 with respect to x. And we can use the formula for integration by parts. We'll let the u term equal the natural log of x, and the dv by dx term equal x to the negative 2. So if u is the natural log of x, then du by dx will be 1 over x. And if dv by dx is x to the negative 2, then we need to integrate this for the v term, which is x to the negative 1 over the negative 1, or negative 1 over x. And now we can substitute each of these into the right-hand side of a formula. So we'll have the u term multiplied by the v term minus the integral of the v term times the du by dx term integrated with respect to x. We can tidy this up. So we've got negative 1 over x, ln of x. This negative and this negative will become a positive, which we can move in front of the integral. And we can write this as x to the negative 2. And when you integrate x to the negative 2, we get negative 1 over x, plus that constant of integration. So this is the answer for part A. For part B, we're told that the region R is under the curve defined here and enclosed between the lines x equals 2 and x equals 4 and the x-axis. So to work out this region, we need to integrate y between the limits of 2 and 4. And we can integrate this by splitting up this fraction. We've got the 3 plus 2x over x squared, and we've got the natural log of x over x squared. And this makes sense because then we can use what we've done here. We have the integral for this fraction, so now we just need to work out the integral for this one. We can divide both of these by the x squared, so we get 3x to the negative 2, and the 2x over x squared will give us 2x to the negative 1. And when you integrate 3x to the negative 2, we'll add 1 to the power, we get 3x to the negative 1 over the negative 1. And when you integrate 2x to the negative 1, well, this is the same as 2 over x, which is the natural log of x, or 2 times the natural log of x. So we can tidy this up as negative 3 over x plus 2 ln x. Now we can use what we have here to evaluate this integral. And before we substitute in these two values, we can tidy this up. We can factor out the negative 1 over x. And we've got the negative 3 over x here, minus 1 over x, so we'll have positive 4, and this ln of x term. And then we have this 2 ln x term as well. So we'll substitute in a 4 for the x, minus, and we'll substitute in a 2. We'll expand out this bracket, and I'll leave this as 2 ln 4. We'll expand out this bracket, and using a power rule, we can move this 2 up to here, so we get a natural log of 4. Now we'll expand out the negatives, so we get the positive 2 plus 1 over 2 ln 2 minus the ln of 4. Now we can tidy this up. We've got the negative 1 plus the 2. The 2 ln 4 take away 1 ln 4. And then the negative quarter ln 4 and the positive half ln 2. If we work this out separately, we've got 1 over 4 times the natural log of 4, which I can write as 2 squared, plus the 1 over 2 ln 2. Now, using the power rule, we can bring this 2 in front, and this becomes negative 1/2. times the natural log of 2 plus the 1/2 log 2. Then you can see that these will equal 0. So what we're left with is 1 plus the natural log of 4. And that would be the area for this region here. Okay? Well, thank you for watching. I hope you found that useful. If you want more practice on integration, you can download the worksheets and the lessons from my website, mrmathematics.com. I'll leave a link in the description below.